This is question number 7 of quiz 13. If a bank has $100,000 of checkable deposits, a required reserve ratio of 20%, and it holds $40,000 in reserves, then the maximum deposit outflow it can sustain without altering its balance sheet is. We have 4 choices here. So what happens is, first you have some checkable deposits. $100,000, and reserve ratio is 20%. So from these two numbers, we can determine the required reserves, which is simply the checkable deposits amount multiplied by the reserve ratio, which is 20%. So that gives us the required reserve. That's gonna be 100,000 times 20%. That's 20,000. But the actual reserves is more than that, right? It's actually doubles 40,000. And then the question is, what is the maximum deposit outflow it can sustain without altering its balance sheet? So to understand what's going on, let's use a typical balance sheet. On the left-hand side of the balance sheet, we have the assets. And then on the liability side, on the right-hand side, we have the liabilities, right? The assets, we have the reserves. That's one of the assets. So that's 40,000. And liabilities, why don't I move a little bit here? So liabilities, we have the deposits, checkable deposits. And initially, it's 100,000. So that's the deposit amount. And so if there's some deposit outflow here means that if some depositors decide to withdraw money from the bank, and then the bank has to pay them, how can the bank pay them? They have to use their reserves, right? They have to use their reserves. Out of this $40,000, use that, because reserves could include void cash. Remember, we said if you check the lecture slides of chapter 9, you can see that reserves here include both, right? Includes both deposits at the Fed and void cash, right? So that's the reserves. So if some depositors decided to withdraw money, that will also shrink these reserves, and they have to be one-to-one shrink, right? Because that's how this balance sheet works. The balance sheet has to be balanced. If you decrease the deposit by 1, the reserves also has to be decreased by $1. And if you decrease deposit by $1,000, the reserves also have to be decreased by $1,000. So that's the point. So from that, we can actually set up an equation and solve out that. So the equation will be, suppose the deposit outflow is X, right? So hence, the remaining deposit, checkable deposit, will be the initial deposit minus this X, because X dollars is withdrawn from the bank. So that's the remaining. And then remaining times the reserve ratio, right? The reserve ratio doesn't change, which is 20% given by the setup. That's the required reserves. And then another way to express the required reserves, given that this is the maximum amount, right? This is the maximum deposit outflow, which means that this amount, the required reserves based on the checkable deposits multiplied by the reserve ratio, will have to be equal to the reserves on the left-hand side. Here it's not, because the actual reserves is $40,000, the required reserves is only $20,000, so there's some excess reserves, and that's because the deposit here is very high. So if you multiply a very high number by 20%, yeah, the number will be well, that's not only because of this number is very high, also because of the reserve is very high. Yeah, both, right? But now if you decrease this deposit, remaining deposit will shrink. Reserves also shrink until the remaining deposit multiplied by the reserve ratio equal to the remaining reserves. So what is the remaining reserves? Right, that's the question. What is the remaining reserves? So the remaining reserves will be 40,000, right? Initial reserves minus this X, because we said the decrease in reserves and the decrease in the checkable deposits has to be 1 on 1, right? If you decrease this one by $1,000, the checkable deposits by $1,000, reserves also has to be decreased by $1,000. So that's why they're both equal to this unknown X. And then this two has to be equal to each other. So you can solve out this using the distribution rule on the left-hand side. You can see that this equals to 20,000 minus 0.2, that's 20%, X times X. All right, this equals 40,000. Yeah, I'm using the mouse, so it's not very beautiful. And then if you move the 0.2 times X to the other side, or maybe it's better to move minus X to the other side. So, and then move this $20,000 to the right-hand side, then the equation will become this. X minus 0.2 X equals 40,000 minus 20,000. And that gives me 20,000. And then this left-hand side will be 1 times X minus 0.2. So it's 1 minus 0.2 X. And that gives me equals 20,000. So this is 0.8 X equals 20,000. So now I can solve out this X. X equals 20,000 divided by 0.8. And this gives me 25,000. So this $25,000 here means if you withdraw $25,000 from the bank for the checkable deposits, then the remaining checkable deposits and the remaining reserves is precisely the required reserves based on the remaining checkable deposits, 100,000 minus this 25,000. So that's what this, and that's why this is the maximum. If you further increase the deposit outflow, you can see that this number will be shrink, but this number will shrink even further, right? Because you can see the coefficient, this is minus X, and then multiplied by a number which is smaller than 1. So if you shrink, if you increase X, the right-hand side will decrease to a larger extent than the left-hand side. And that's why this is the maximum. Yeah, otherwise, the right-hand side, which is the remaining reserves, won't be sufficient, will be smaller than the required reserves. then the bank has to change its balance sheet. But the requirement here is that the maximum deposit outflow it can sustain without altering its balance sheet. So that's why C is the answer. And the input is correct. But I want also to show you another way to get the same number by using Excel. Remember, we're going back here. So how can I use the Excel? You just deposit. I write down another term on this balance sheet. Okay, this is the deposit outflow. So I just write down a random number, 20,000. Yeah, obviously this may not be the final answer, but right now it doesn't matter. Again, because decreasing reserves, okay? And then this has to equal to this deposit outflow. Yeah, as we explained. These two numbers have to match, otherwise the balance sheet cannot be balanced. Yeah, right now you see these two numbers do not match, and that's because there are other items on the balance sheet which I didn't list yet. But if you decrease the deposit by a certain amount, reserves also have to be decreased by that amount because the bank has to use the reserves to pay the consumers, to pay the depositors. And that's why these two numbers have to be the same. So now, let's set up the equation. Equation here is the required reserves. The required reserves will be this initial reserves minus this initial reserves minus the decrease in reserves, right? So that's the required reserves. That's one way. And another way to express this is because the remaining deposit is simply the initial deposit minus the deposit outflow. Or this is outflow, not output. So required reserve using the remaining deposit is basically this amount times 20%. So obviously, because I assume this deposit outflow, you can see that this number is required reserve by using the checkable deposits. Using checkable deposits, and this required reserve is based on using the decrease in reserves. Yeah, these two numbers do not match, and that's because I artificially assumed this deposit outflow. But right now it's not a problem because I can change and then I can, in order to use I want to use the data and what if analysis here and goal seek utility, this tool in Excel. But because if you open that goal seek, you can see that set sale value has to be a specific value, so you cannot directly make these two sales to equal to each other, and that's why I also have to calculate the difference between these two reserves. Difference between these two reserves. One reserve, required reserves, is from the decrease in reserves from the initial reserve amount. Another required reserves is from the remaining checkable deposits multiplied by the reserve ratio. So the difference between these two will be this number minus this number. Okay, so right now there's a difference. But I want to make these two numbers to equal to each other. And so my goal is to make this difference to be 0, right? So now I can use the what if analysis in Excel and goal's sake. So, and then I want to make this B10, exactly B10, the cell B10 to be 0, right? To be 0. By changing which cell, remember we said this initially, this deposit outflow, that's our X. Yeah, that's our unknown here. And all other variables are based on this unknown. So then if I change this unknown, this number will also change. And you can see that. So you see, now Excel has helped me to figure out if deposit outflow equals this $25,000, then the difference between the two reserves will be 0, which means these two reserves will be the same. And that's my target. Right? Decreasing reserves also were the same as that one because I assume to be these two to be the same. And that's why here you cannot directly write down the number. You have to equal to the cell value here. And also here, you cannot write down directly the value. You have to use the formula. Yeah. So you can see that the maximum deposit outflow here, calculated by Excel, is the same as the value which we calculated from the from our hand. So both ways give us the same answer.